So in this video we will be taking a look at phase difference. We are looking at this concept because we have something called the phase difference between the current and the voltage in AC circuits. When you have an inductor or a capacitor connected to AC supply, then there is a phase difference between the current and the potential difference applied. So in that context we are going to look at what is phase difference. So phase difference is a general term which applies to waves, phenomena which are related to waves. So before we discuss phase difference, let us talk about what is phase. In wave motion, when something goes in the form of a wave, you can have, for example, a spring. This is a spring attached to a mass, and this is the relaxed length 0, and if you displace it to another location and release it, then it will start oscillating back and forth. So this will be an oscillatory motion, but corresponding to this back and forth simple harmonic motion, which we will not get more into, there is a circular motion, a uniform circular motion to be more precise. So this can be projected on a circle. So you have a circle like this. So when the particle is over here, you can think of when the object is over here at the extreme, you can think of the object being here. As the object goes over here, you can think of the object being here. When it goes over to the other side, you can think the object being here. When it is at the 0 position, the object is over here, and when it is back to where it started from, the object is over here again, and the cycle repeats. So basically what you have is, if you have a light source overhead, then the shadow of this particle will exactly fall on the object performing the simple harmonic motion. So that is what we mean when we say that we project the object on the linear motion of the object on the circular motion. So these are equivalent. So circular motion and this simple harmonic motion are equivalent, and this circular motion will be called UCM. UCM in the sense uniform circular motion, and so this is what we have. So any oscillatory motion, simple harmonic motion, the point here is any oscillatory simple harmonic motion can be projected over a circular motion. Okay, so now we come and talk about circular motion exclusively. So consider a circular motion. The particle is over here, and let's say this is the x-axis and this is the y-axis, and the particle starts from here and goes in circle like this with a constant omega. And let's say the particle is starting from here at time t is equal to 0, and this is the x-axis, this is the origin, and let's say this distance is a. Okay, now I can write the equation for this x, the location of x. So I project this on one dimension, the way one dimension was projected into circular motion. So the particle will appear to move back and forth between x is equal to a and x is equal to minus a. This is minus a. Okay. So the equation that I can write for this particle's motion is x is equal to a cos omega t. So at time t is equal to 0, x is equal to a, and we can make that out. and at time t is equal to capital T by 4, for example, then you can do the calculation and see that it exactly follows cos omega t. So x is equal to a cos omega t is an equation for this. Okay. Now coming to our question, what is phase? Okay. Let us say the particle did not start from here, that is x is equal to a when time t is equal to 0. The particle instead started from some random location. Okay, some random location. Of course, it will have some angle. This angle over here, let us call it phi. So if the particle had been starting from this location at time t is equal to 0 rather than this, then what would the equation become? If you work out the mathematics, you will find that the equation becomes this. X is equal to a cos omega t plus phi, and this angle phi is called the phase. Is called the phase of this oscillatory motion or the wave motion. Okay, so this is what we have as phase. So it is basically the angle. Okay, so now let us discuss what is phase difference. So of course, when we talk about difference, you are comparing two things, minimum two things. You cannot talk about difference of one thing. So you have two things to compare, and of course, if you are discussing phase difference, then we have two oscillatory motions or two waves into consideration. So let us say we have one oscillatory motion performing uniform circular motion, and we have another particle performing uniform circular motion, and let's say this is starting, this particle A is starting from with some phase difference phi 1. Phase difference, phase is phi 1 for this particle A. So this particle is going round and round in circles with a certain omega. Is that okay? And let's for simplicity keep this particle also having omega, the angular velocity as omega. So both are going in circles with the same angular velocity. Now let us say that this particle which is performing circular motion, let us call it particle B, started from this location over here. So it has a phase angle of say phi 2, and you can see clearly that phi 2 I have drawn to be greater than phi 1. Phi 2 is larger and phi 2 is smaller. And let's say this is the situation at time t is equal to 0, and this is as well at time t is equal to 0. So both are supposed to go in circles with same angular velocity. So you start your stopwatch and the particles appear to move in circles. Is that okay? Now you see, if I project this over here, then the diagram will look something like this. So this is the location for B, okay, and if I draw the face, the starting face of this, then it is this phi 2, okay. So what will be the motion looking like? This B will be always appear to be ahead of A, and the particles will go like this. So there will always be some angle between the two. So they will go like this, okay. And this angle between the two is basically the phase difference between these two motions. So phase difference over here will be phi 2 minus this angle, phi 2 minus phi 1. So phase difference, here the phase is phi 2, So the phase difference for these two uniform circular motions is phi 2 minus phi 1. So this is what we mean by phase difference. So now let us talk about some special cases. If the phase difference is 0, if the phase difference is 0, then these particles will move, give us identical motion. Yes, by the way, I did not mention, let the radius be also the same. Okay, radius of the circle. So if the phase difference is 0, then these two particles, which are, I mean, clearly distinguishable, are giving us identical motion. So they go like this in circles, they are in phase. Okay. If the yes, by the way, phase difference 0, we also call it as in phase. Any phase difference which is not 0, we say out of phase, or more especially when the the phase difference is pi, but we will come to that. So now let us talk about phase difference pi by 2. By the way, phase difference can only be an angle. Phase difference is pi by 2. It is an angle. So phase difference is basically an angle. Now if the phase difference is pi by 2, then what you have is the particle A is starting, say, at here at this position, the particle B is starting at this position. Okay. So there is a constant difference in angle, and that difference is pi by 2. So when A has reached here, B has reached here. Okay. And when A has reached here, B has reached here. So there is a constant phase difference of pi by 2. How will the motion look like if the phase difference is pi? Okay, then the motion will look something like this. For example, A has reached here all the way to the other side of the diameter, diametrically opposite position from here to here, and the particle B starts from this location. So there is an angle, difference of angle is pi, 180 degrees. Okay, and the motion will look something like this. Okay, so the phase difference is now pi between these two particles A and B. So the motion looks something like this. Okay, phase difference of 2 pi, 2 pi. By the way, 2 pi and 0 are roughly speaking equivalent, but what is the difference over here? If the phase difference is 2 pi, the difference is that when you start your stopwatch at time t is equal to 0, the particle A starts to move, for example, but the particle B will start to move after one complete revolution of particle A. So the motion will look something like this. At time t is equal to 0, you start, it goes like this, sorry, this remains here, it goes like this, and then this starts. Okay, so this is what you have, and so on and so forth. So this is what we have as phase difference between two uniform circular motions, or two waves, or two simple harmonic motion, any two oscillatory motion. So this is what we have as phase difference, and this concept, this terminology will be used in one of the concepts in alternating current. So I hope you understood the concept, and I will see you next time.